Here are 4 drivers of AWS Lambda costs that support the Rust runtime. First up here, we have invocation count. You're charged by how many times you're invoking a Lambda. So essentially every time it gets called, you're going to pay some cost here. So a Lambda function is a function that can quickly add up. And so if you're using lots of applications and building things with lots of invocations, you're going to need to monitor and optimize those triggers to make sure that they're actually successful. And the second driver here is execution time. So the execution time is how long it will take to process an event here. Now, this is where computational speed is really critical, because if you can do things in milliseconds and you get, in the case of Rust over Python, there's many scenarios, like for example, the rough linter could show us that you could do 10 to 1,000 times performance over regular Python based linting. You can see with other bits of code, there's going to be similar scenarios here that you could save, anywhere from 10 to 1,000 times on execution time, so your build time. The other one that's really hard to get around here, no matter however you optimize your Python code with C, etc., you can't get away from the fact that Python uses more memory. There are recent studies that show around 70 times more memory is used by Python than Rust, and so you're going to have to use a bigger allocation for the runtime, and that's how the pricing works with AWS Lambda. So you're going to pay more money because there's more money in terms of the memory allocation at play. So you're just wasting, let's say, a larger instance that can run with Rust here. So when you configure a Lambda function, you can set the amount of memory available to the function, and this is going to implicitly allocate the CPU power, the network bandwidth, etc. So you're kind of limited by how memory inefficient Python is. Now, the other one that's kind of a stealth one here that not a lot of people talk about is that Python doesn't support true threads. And so one of the problems is that if you are using a Lambda, let's say a large memory Lambda that has 4 or 6 cores, etc., they're going to sit there idle unless you do something fancy like use processes, which in turn also increase more memory. So you're kind of stuck here between a rock and a hard space with this true threads here. But with Rust, you can open up threads here, use, let's say, the Rayon library, automatically handle a thread per core without doing much work at all. In fact, you can just work through an iteration and actually have a thread per iteration that hits a core. So there's really not much to do to be able to use fully the multi-core environment in Lambda by using Rust. So when I hear people say that data engineering at scale works well with Python in serverless, I think this is like saying, chocolate cake can help you lose weight. It's true in theory if, let's say, you starved yourself for 7 days in a row and then had one piece of chocolate cake, you could lose weight eating chocolate cake. But that's not really telling us the whole story here, is that Rust is just orders of magnitude more efficient than Python for serverless. And it's up to you to really figure out where you can put this in your workflow, and you can really save a lot of money by using the Rust runtime.